Hello friends, so today I'm going to discuss the solution of IIT JAM Physics 2021 question paper, and I'm going to discuss the mathematical physics portion right now. Uh, I have discussed the thermodynamic portion earlier in my previous video. So in this video I will be discussing about the mathematical physics. So in this section A, the first question that was asked in that let M be a 2 cross 2 matrix. uh, its trace is 6 and determinant as value 8, its eigenvalues are. So basically it's we 2 cross 2 matrix was given and its trace and determinant was given and eigenvalues were asked. So we know that the uh, a square matrix, for a square matrix, the sum of the eigenvalues is the equal to the trace. That is, if it is 2 cross 2 matrix, the eigenvalues will be, let's say, alpha 1, alpha 2. So alpha 1 plus alpha 2 is equal to 6, and the determinant is product is equal to the product of the eigenvalues, that is alpha 1 times alpha 2 is equal to 8. If we solve these two equations for alpha 1 and alpha 2, we'll get alpha 1 is 4, alpha 2 is 2. So option 3 is the option which are matching with the answers. The next question was the function e to the power cos x is we have to is Taylor expanded about x equal to 0, the coefficient of x square. So and the Taylor series expansion of e to the power cos x around x equal to 0, we have to find out that what is the coefficient of x square. So for a given function fx, if I write down the Taylor series expansion about that point x equal to 0, which is nothing but the essentially the Maclaurin series, which is fx equal to f0 plus x over factorial f prime 0 plus x square over factorial 2 f double prime 0, etc. The higher terms x cubed by factorial 3f triple prime 0, where prime denotes the differentiation with respect to x, and then we have to calculate that value of the differentiation at x equal to 0. So coefficient of x square occurs here if you see carefully, because this is x and this will be typically a value. So this will also be typically a value. So this will also be a value. The only x square term comes from this expression here. Next will be x cubed. So f double prime 0 is the by factorial 2 is the coefficient of x square that I've written here. And with this information, we need to really calculate f double prime x first of all. So fx was given e to the power cos x. If I differentiate f prime x, it gives me e to the power cos x times minus sine x, and then I have to differentiate one more time to e to the power cos x as it is, and differentiation of minus sine x is minus cos x plus minus sine x is as it is, and differentiation of e to the power cos x is e to the power cos x minus sine x. All right, and then I have to calculate this f double prime x at x equal to 0. So if I put at x equal to 0 in this expression right here, so what do you see that at x equal to 0, sine square x will going to give me 0. So the second term is essentially 0, and the first term cos 0 will be 1, and e to the power cos 0, which is e to the power 1. So that's it. It means f double prime 0 is actually uh, minus e. So if I know this, that f double prime 0 is minus e, I have to simply substitute the value of this in the coefficient of x square, which is f double prime 0 by factorial 2. I have to put the value here, and I put the value of f double prime 0 in this coefficient of x square. I get minus e by 2, which is matching with the option A that was given to us. Okay. All right. So next question was let x comma y denote the coordinates in a rectangular Cartesian coordinate system C. Let x prime y prime denote the coordinates in other coordinate system C prime, defined by these transformation rules, these transformation equations, that x prime connects with xy by this equation, and y prime is connected to the xy with this transformation rule. The area element in the new coordinate. So the area elements are connected by the Jacobian, and this is how they this is the area element in the new coordinate system, this is the area element in the old coordinate system, and this guy here is known as the Jacobian, which is equal to del x prime over del x this is the determinant, that del x prime over del x prime by del y prime del y prime del y. We calculate this and we get it to be 17. So in this coordinates system, with respect to the old coordinate system, the area element of dx dy, which is equivalent to with respect to the new coordinate system as 1 over j dx prime dy prime, which is 1 over 17 dx prime dy prime, which is matching with the option 1. So option 1 was correct. Then the next question was the solution yx of the differential equation y dy by dx plus 3x equal to 0 at y1. This is the initial condition given y1 at x equal, that is y at x equal to 1 is 0, described by what? So if we take the given differential equation y dy by dx equal to minus 3x, and we solve it by variable separable and integrate it, we get a constant of integration which we can calculate with the help of the initial condition at x equal to 1. When we put the initial condition at x equal to 1, y equal to 0, then with the help of this we find the c1 is nothing but 3 by 2. We'll put this c1 back here, and this is the equation we get. And after rearranging this, we get the value as this basically 3y squared by 3 equal to 1 minus x squared, or x squared plus y squared 3 equal to 1, which is essentially equation of a of an ellipse. Okay, so it's just semi-major axis as 1 and semi-minor axis as root 3. Okay, so this is an ellipse. This the question is related to the Fourier series. In the Fourier series expansion of two function f1t equal to 4t squared plus 3 and f2t is 6t cubed by 7 plus 7t in the in the interval minus t by 2 to plus t by 2. The Fourier coefficients a n and b n are the coefficients of cos and omega t sine and omega t respectively. Then which of the conditions are satisfied? In the conditions were asked that an is not equal to 0, bn is not equal to 0 for f1t, an is 0, bn not 0 for f2t, and similarly others, that which coefficients are 0 for which function. Basically that is the this is the question in front of us. So if we look carefully, the f function f1t is an even function of t, f2t is an odd function of t, right? So we know that in the Fourier expansion of an even function, an is are the coefficient which are expected to be non-zero, and bn will be 0, because if we look at the Fourier series expansion of the function of ft, for example, any function, this is the Fourier series expression of the Fourier series expansion, where ft is periodic in the interval minus l to l with period 2l. Here the l is t by 2 given to us, minus t by 2 to plus t by 2. So this is the expression for the Fourier series expansion, and a 0 and ans are calculated by this formula, 1 over l minus l uh, to l, with period of the function is 2l, and it is defined in the minus l to l. So ft cos and pi t by l. So here t is t, but l is t, capital T by 2. So if I put capital L t by 2 here, so it will be cos. If I put here, what will become this cos and pi t by l will be cos n pi t capital T by 2, right? And 2 pi by t in this is nothing but omega, right? So I can actually write down it as cos n omega t. Right. So basically, this was asked in the question. The an and b are the coefficient of cos omega and omega t and sine and omega t. So this guy here is actually cos and omega t. I can write it as cos and omega t. Similarly, here I can write this thing as sine and omega t. And similarly, in here also, this can be written as cos and omega t, and this can be written as sine and omega t. So basically, we have to find out these coefficients a and b, which are the coefficients of cos and omega t and sine and omega t respectively. But which one is 0? So if you look carefully, the expression, the formula for the although it's a very standard result, everybody knows, remember this result. So that the coefficient an for the odd function will be 0, because cos is an even function. If ft is an odd function, the product of this will be odd function, and with the property of the definite integer, it is going to be 0. Similarly, if ft is an even function, the product of two even function is even function, is going to be non-zero. And the case is reversed for the case of bn. If ft is an odd function, the product of two odd function, because sine is an odd function, odd product of two odd function is an even function, so bn will be non-zero in that case. But if ft is an even function, then bn will be 0. So if you look carefully, our first function is an even function, so and f2 is an odd function. That means by that same logic, for even function, that is for f1t, we are going to get an as non-zero and bn as zero, while the for the f2t, which is a non function, we'll get bn to be non-zero and an to be zero. So the option which is matching with this condition is option 3. If you look carefully, ans are non-zero for f1t. F1t was even, and f2t was odd. So option 3 is matching with this. This is pretty standard thing in Fourier series expansion. Okay, so in the section B, a time-independent conservative force F has the form F equal to 3y I hat plus fx comma y j hat. So this was not given to us, fx comma y. Its magnitude at x equal to y, x equal to y equal to 0 is 8. So the magnitude of the capital F is 8 at x equal to 0, y equal to 0. The allowed forms of fx comma y. So we have been asked to find out the allowed forms of fx comma y, which are the allowed form of x. So if you look here, the capital F at x equal to y equal to 0 is 8. So if I put y equal to 0 here, and this I don't know, so f0 comma 0 turns out to be 8. Okay, so this is the condition. If you look here in the options given, so every option actually satisfies this condition. So we are will not be able to find out which form is valid from this condition. We need to explore something more. And it has been given this conservative force, and the conservative force can be written as a negative gradient of a potential, or its curl is 0. So if I take the curl of f, del cross f, that to be 0, and if I calculate with the help of this curl, I get del f by del x equal to 3. That is the first derivative of f x comma y, partial derivative of fx comma y with respect to x has to be 3. So if we look carefully, see the option 2 and 3 satisfy this condition. Because if I take the derivative of first and 4 with respect to x partially, is going to give me 2 rather than 3. So options 2 and 3 are the correct option. Okay. Okay. So the next question, one of the roots of the equation z to the power 6 minus 3 z to the power 4 minus 16 equal to 0 is given by z1 equal to. So one of the root is z1 equal to 2 out of 6 roots. The value of the product of other 5 roots. So we have to basically find out the product of other 5 roots. So this is an even degree polynomial. So for an even degree product of roots is c by a. C by where c is the constant terms in the polynomial, which is minus 16 in this case, and by a is the coefficient of the highest degree term, which is 1 here, so minus 16, and one of the root is given as 2, so rest of the roots will have a product as minus 8. Had it been an odd degree polynomial, then we'll have to write down the product of the roots equal to minus c by a instead of c by a. Okay, so we put a minus in that case, but in this particular case, this is an even degree polynomial, so the product is pretty much like quadratic equation c by a. So understand it well. Thank you so much.